Hi there, I'm Dr. Rob McLeod and I am an Associate Professor in Building Physics at TU Graz in Austria. I'm going to explain to you today how to assemble a mechanical extract ventilation system which was designed by aerosol scientists at the Max Planck Institute for Chemistry in Germany. Many highly infectious diseases like Covid-19 and common colds are transmitted through the air via aerosol bubbles that humans emit when they breathe, talk, sing, and shout. This is why a good ventilation system must provide a means of removing these very small aerosol particles as efficiently as possible. This in turn lowers the CO2 concentration in the room by providing a continual supply of fresh air, which has been shown to improve students' concentration and performance in class. In the next 10 minutes, I'm going to explain to you how to assemble this mechanical extract ventilation system for use in naturally ventilated educational spaces. First, you will have to install the extract fan or ventilator in a centrally located window. There are two main options to install the fan in a window opening. The first and simplest option is to remove the window casement and replace it with a 5mm sheet of polycarbonate or a timber insert panel. That option is not always possible, and when the window is not on the ground floor, it may be safer and more straightforward to construct an internal window box. The window box is made from a timber frame construction of 40 by 40mm timber batten. The window must always be open whenever the fan is in use to allow the stale air out, and closed the rest of the time to avoid excessive heat loss. This means you need either an access hatch on the side of the window box to be able to reach the handle, or you can use a sealed system with an OL90 mechanical hand lever to open and close the window. The frame must be sufficiently wide that the window inside it can be opened in tilt mode without hitting the fan. There are different types of axial fans which can be used as the ventilator. V-direction axial fans have a metal flange on the upstream face of the fan, and that makes it easy to fix the duct to them. Once the fan is installed, the system can now be run as a simple room extract system without any further additions, and this will improve the room air quality. However, by adding the ductwork to the system, we can improve the overall performance significantly in terms of removing aerosols from all parts of the room. The main ducts can be pre-made in sections before bringing them to the room. The main duct is formed in two layers. The outer layer is made from a clear polythene sleeve. The outer sleeve should be about 7 centimeters longer than the inner mesh, allowing it to overlap the connection pieces to which it is fixed. An inner layer made from a plastic mesh is formed into a 30 centimeter diameter cylinder in order to provide support for the outer sleeve. The main duct sections are connected together by a series of polypropylene junction sections which are designed to connect the branch ducts to the main duct. The main duct is then fixed to these connection pieces using a 1 meter long cable tie to seal around the perimeter of the main duct where it overlaps the connector piece. If you can't find a cable tie that long, you can also use some airtight tape. Before the main duct is lifted into position, the fixing points need to be installed in the ceiling. The main duct is very light, but it is nonetheless important to place the secure fixing at approximately 1 meter intervals across the ceiling to hold it securely in place. Here we're using plastic raw plug anchors which have been placed into pre-drilled holes extending out across the room. It's helpful to use a portable laser to make sure the line is straight, but you could also use a piece of string and a spirit level. We recommend using lightweight galvanized steel chain to suspend the ductwork. This is easy to work with and also fire resistant, which means the system will remain suspended in the event of a fire evacuation. The chain also makes it easy to fine-tune the ductwork so that it is uniformly level. The chain can be fixed to a ring hook fixed to the main duct, or if greater security is desired, a wire hanging loop can be created using copper wire wrapped around the duct. Once the fixing hooks are in position, the chain is attached to the main duct and it can be lifted into place. Although it is very light, it is good to have a number of spare hands available to assist with the lifting into position so that it can be raised and held level whilst being fixed in place. Once the main duct is suspended and correctly aligned, it can be fixed to the fan. The system can be run like this, with stale air now being extracted from multiple points across the room. The branch ducts are pre-made in sections in the same way as the main duct, just with a 90mm diameter plastic sleeve. The outer sleeve should be about 5 centimeters longer than the inner mesh, allowing it to overlap the connection piece to which it is fixed. The hoods are pre-assembled using thin polythene sheeting or cellophane, which is wrapped around a circular wire frame and either stapled or taped into place at the edges. It's important that the hoods are not too taut, as they should form into a shallow cone shape when they are suspended in a level position. The cone shape is designed so that the hoods catch the aerosols as they rise up on the warm air plume rising off the person seated below. A 90mm diameter hole is cut into the center of the hood so that it slides over the elbow connection at the extract terminal. The branch ducts run from the connection points on the main duct out to the position of the extract terminals in the room. It is important to measure the length of the branch ducts accurately, as they must end up with the extract terminal in the correct position above the desk. The branches are fixed to the main duct connectors using a 300mm long cable tie. Once all of the branches are installed, stale air can be extracted from all zones of the room. Adding the hoods to the terminals will further improve the system performance by removing aerosol contaminants from the occupants before they can escape and circulate in the room air. Once all the hoods are installed, the system is complete and ready for testing. Quality assurance is important to ensure that the system is operating correctly. Here we make a quick visual inspection and leakage audit to check that air is flowing correctly through the ducts and there are no unwanted leaks in the system which could cause pressure drops. You can use a thermal anemometer to see whether air is leaking at any of the connections around the fan or at any of the ductwork connection points. Alternatively, you can also use the back of your hand to feel for any drafts or airflows around any of these points which could indicate an air leak which needs attention. It's important to operate the system using a CO2 sensor in the room to give feedback on the air quality, which provides us with a good indication of the risks of viral infection in the room. Finally, it's very important to place a set of operating instructions in the room next to the fan controller and to brief the room occupants on the correct usage of the system.